Hello, my dear friends. Hope all are fine, all are doing good. I am here today with another useful electrical project, which is IoT based load parameters monitoring system. So, objective of this project is to monitor the various electrical and non-electrical parameters of the load, so that this data can be used for understanding the load pattern of a particular consumer for a given period of time, so that we can forecast the power generation or distribution, transmission, and so on. I have done this for few loads, but which we can use it for consumers, a different level of consumers, and these data can be analyzed. Say a particular street, a particular area. If you have 100 or 200 consumers, we can have this system to monitor how the consumer is consuming the energy in different period of year, like summer, spring, and different times. And even per day, we can also say from morning, afternoon, evening, night, so that we can calculate the peak load, and we can have the power generation, forecastings, distribution, so on. Okay, so this is a wide scope uh, project. So we have done only a initial step. So this, from this you can go on to do lot of the future things as well. Let us see how we have done this using a components like what we have listed here. The major components are energy sensor, which is used to measure the various electrical parameters of a given load. Temperature and humidity sensor, which will measure the temperature and humidity of an ambient condition for the given consumer or a load. Pressure sensor, which will give the pressure as well as the temperature as well. Arduino Mega is a controller which we use to collect all this data and to communicate with a ThinkSpeak server. ESP8266 is the Wi-Fi module which we used the interface between the Arduino Mega and the ThinkSpeak server. RCD and MCB is a protective devices since we use the live loads, so we need a protection. Safety is very important. So we have RCD and MCB. So RCD is a residual current device. So the trip current is 100 milliampere here. So you can prefer 30 milliampere as well, so that it can give more protection for the particular consumer, a particular circuit. MCB, I have used 20 amperes since I have connected the socket outlets as my load, and from the socket outlet I can connect any loads, so that I have chosen 20 ampere MCB here. So based on your load you can choose the MCB rating as well. So the transformer I used here to step down the voltage, so that I can get a DC supply for running all these sensors and powering all these units. A relay unit to control the load in case of overload or low power factor and uncertain conditions. So if you want to turn off the load from remotely from a distant place, we can use this relay. So this is the major components of this particular project. The wiring diagram is shown here. So in the wiring diagram you can see the energy sensors. As I told you, I have connected 4 different loads to be monitored. So 4 energy sensors are used. If you are using as a consumer, one particular consumer, one energy sensor is enough, which you can connect in the main distribution box. since I want to monitor each individual loads, so I have connected 4 energy sensor for 4 different loads. For one consumer, if you want to analyze the load behavior of that particular consumer, you can connect one energy sensor with all these sensors, whichever you require, whichever the parameters you want to monitor, you can connect these sensors, and then you can analyze the load pattern. Okay, so since I'm checking each and every load of the particular consumer, I have used each and every load with a one energy sensor. Right, so we have pressure sensor here. So it's a very simple wiring configuration here, SCL SDA for communicating the data, and power supply VCC and ground. And this thermal sensor I am not used here because DHT11 and BP 180 both can give the temperature values. If you want read the temperature of any particular device, like for example the load temperatures, okay, like motor or any device which you have, you want to observe the temperature of that particular load, you can use this thermal sensor, and this DHT11 can give the ambient temperature. Okay, so that is for the future scope. And ESP8266, as I told you, this is used for communicating the data to the ThinkSpeak server from the Arduino Mega. So this is the wiring diagram. Let us go into each and every components here. So these devices, protective device and transformer picture, just for your reference. This one is RCD, residual current device, and MCP, both are double pole devices, and this is a step down transformer. A DC power supply unit to give the power to all these sensor and Arduino Mega and everything. So I have used a DC power supply unit which I have designed. I have a AC to DC rectifier unit and a voltage regulator, and then filter capacitor. Relay unit, as I told you, in case of any abnormal conditions, we can use these relays to control the load, to avoid the to avoid any uncertain things, or you can also use this for controlling the load. For example, already it is in a peak load, you want to turn off the power for some AC from different location. Your house is in one place, and then you want to remotely control your load. You can control this because this is connected to the ThinkSpeak. So from the ThinkSpeak, you can turn on or turn off the relay, so that the load can be turned off and turn off in your home. So from anywhere in the world, you can control the load in your house or in your particular place. So that is the purpose of the relay. So you can have two purpose: one, to manually control it from the remote place, and the second purpose, in case of any abnormal condition like over voltage or under voltage, or over current or low power factor, this sort of abnormal conditions. So because you are getting all the data, so you can just add a condition: in case of overload, or in case of over voltage, turn off this particular load, or in case of peak load time, turn off this. Any sort of logic can be written. So for that purpose, this relay can be used. And PZEM004T, I have explained this particular sensor, and interfacing this sensor with Arduino, uploading the data to the ThinkSpeak. So I have explained it. So if you have not seen those video, please go through this link, and you can understand that, because this project is a little bigger one, so I cannot explain it again and again. So please go through this link and you can understand that. So this is the wiring diagram for this energy sensor, which is going to give all the electrical parameters like voltage, current, power, energy, power factor, frequency. All these electrical parameters of that particular load you can obtain using this energy sensor. So this is a simple code for obtaining the data. As I told you, I have explained it in the another video. You can just refer it. And this is for DHT11. where I can get the temperature and humidity of the ambient condition. So again, this also I've explained in the another video, so which is given in this YouTube link. You can just refer it, so that you will understand what is DHT11, how it is working, how the data is obtained, how it is communicated with the ThinkSpeak server. So this is the data for obtaining that sensor values, and this is ESP8266 pinout. So very simple pinout. So we have a power supply unit, and then we have transmitter and receiver connections. So it will be connected just like this. Okay, so only 5 terminals to be connected, 3 pins are not used. And that energy sensor data, how to communicate using this Wi-Fi module to the ThinkSpeak server. For that, this is the code. So as I told you, this code is explained, and uh, in the another video it is explained and then shown how it is communicated. So you can just go through that. BMP 180 is a pressure sensor. So this pressure sensor is used to measure various parameters like atmospheric pressure and sea level pressure, altitude, temperature. So all these parameters can be obtained using this BMP 180 sensor. So it is also having 4 pins for connection. So as I shown here, so we can have positive power supply and ground, and SCL, SDA for communication between the Arduino and this BMP 180 sensor. How this BMP 180 sensor is working is about so this is, if we know that actually air has its own weight or mass, so that it exerts some pressure on atmosphere. Yeah, so because of the gravity, it exerts some pressure on the any object which is in the atmospheric condition. So this is actually the BMP 180 is a piezoresistive sensor. Okay, so when the pressure is applied on this sensor, it gives the output with respect to change in resistance. This change in resistance can be measured, and it will be calibrated in a voltage signals. Okay, so it's a piezoresistive sensor, and it is made up of semiconductor material, usually silicon. So that changes resistance when a mechanical force like atmospheric pressure is applied. So this is what I told you. So when you apply a pressure on a piezoresistive sensor, so the resistance will change. When you apply force, then the resistance will change. It will be calibrated as a output voltage, so which we can calibrate again into pressure. In the units of pressure, we know that it is measured in Pascal in SI unit, so or millimeter of mercury. So these two units we can use for measuring, and sometimes you can see in mega millibars, okay, bar, and that is also a pressure unit. So let us see the code for the project. So there are some declaration part. So any Arduino code will have 3 parts as a skeleton. So we need to declare first the header files, variables, all those things. So that is first part, and the second one is a setup part. So where you will begin the process, like you want to begin the LCD, you want to begin the serial port communication, you want to begin the Wi-Fi module communication. So there are a lot of communications, so we need to start those process, so that will come in the setup, and then finally we will have the loop where the logic will be executed, or where the data will be obtained from the sensors continuously, and we will have certain logics to get the output with respect to different programs. So now let us see how we are done the code. So first, as I told you, we need to declare few important header files. So we are using different sensors. So this BMP 180 is a pressure sensor. I am declaring it, and this is wire.h to communication. This is one header file, so which we are using it when we are using this PZEM004, and then we are declaring certain variables also, altitude and in meters. So this we will see how this variable is used for calculating pressure later, and pressure and altitudes. And this energy sensor header file, this Arduino header file, and these are Wi-Fi module header files, and this is a ThingSpeak header file. So once we declare all these header file, still we have a few more things to declare. So we need to say the SSID of your modem, that is your Wi-Fi modem, and password of your Wi-Fi modem. So I just represent it as X. So you can give the SSID of your modem here, and then password here, and then also we declare we include the DHT11 header file and some variables to obtain the sensor values, val and pre relative pre, that is pressure, relative pressure, and PIR sensor. So though we have not used this for the future purpose, I declared it. Okay, so these are some variables, and then here you can see uh, you know uh, RX and PX pins where the energy sensors are connected. So where different energy sensors are connected with this RxTx pins. So this RxTx pins can be of different numbers. So as per your requirement, you can change these numbers. And also for the Wi-Fi module to communication between the ThingSpeak, so we need to give some data. So you need to give the channel number of your ThingSpeak channel. In the previous videos, I have explained about the ThingSpeak, how the ThingSpeak login account can be obtained, and the channel numbers and API key and all those things. So if you not referred, please go through that video so that you will get those informations. Okay, so this channel number of your channel and then API key, so you will get from the ThingSpeak server. So you need to mention it here. So this will be different for your channels. So for my channel, I got this one, and it will be different for each and every channel. So that is about the declaration part, and we have a setup part here where we are beginning. As I told, we need to begin many things like serial port communication, and then Wi-Fi, ThingSpeak, pressure sensor, this one conditions, all those things we need to begin. So the beginning process are done here in the setup mode, and then also we will come to the loop here. So where again we declare some parameters to obtain the variables from the BMP 180 sensor. So temperature, pressure, and then relative pressure, and then we have altitude. So these are denoted with these letters. So we can have any different names. We can write as a temperature itself, pressure, relative pressure, like that. I just declared T for temperature, P for pressure, and P0 for relative pressure, and D for altitude. Okay. So also I have a simple this one, like I'm just printing those things in the serial monitor. So this is not essential part. If you want, you can do this. Otherwise, you can directly go to get the data. So here I am getting the temperature first from the BMP 180. So this is the um, sub function. The function start temperature of this function brings the data from the BMP 180, and it stores the value here in the status. So if the status is not equal to 0, if this condition, when you get some value, so it will not be equal to 0. So when this is not equal to 0, then it goes inside and it gets the pressure, temperature. Okay, so it gets the temperature, and if again you get the value, once you get the value, print the value here, temperature value. You are printing the temperature value in degree Celsius. Okay, so you get it in the degree Celsius, And then if you want to show it in the Fahrenheit, so this is the formula to convert the Celsius to Fahrenheit. So you can convert that value and you can show it in a Fahrenheit. Suppose if you want only degree, you can stop at this point itself. And after this, you need to get the pressure value. So again, pressure dot start pressure off. So this function brings the pressure value and stores in the register called status. If the status is not equal to 0, then get again pressure and temperature off. So again it checks the status. If not equal to 0, you get absolute pressure, so which will be written as P, and it will be displayed in the serial monitor. And then the unit of this is a millibar, so it is also displayed in the serial monitor. So if you want to convert into inch mercury, so this unit you can convert that millibar into mercury in inches using this formula. Using this formula, you can convert this. So this is the formula. Just we are printing it, and then we are getting the pressure in inches in the mercury. So then you can declare that you can print that value as well. Okay, right. So pressure at sea level P0, again this is a function pressure dot sea level of P comma altitude. So this can be different for your location. We have to check and we have to put this one, and then we are getting the value of the pressure, relative pressure, and we are printing it in the. So this is the relative pressure you get. So we are printing it in the. So this function will bring the relative pressure, and it will store in this register P0, and we are printing it in the serial monitor. The unit is MB, millibar, and if you want to convert into HG, inches, so you can convert using this formula. So now you can see temperature we obtained, and then absolute pressure we obtained, and then we got the pressure at sea level, and then now we can also get the altitude using this formula, pressure dot altitude P comma P0. So this is the function. So these are predefined functions when you are using this header file. So these are predefined functions. So whichever the data you want, only take those data, and remaining if you don't want the sea level pressure, and you don't want say for example altitude, you can neglect these parts. Okay, so I have shown everything, so whichever you require you can use that, remaining things you can just leave off. So this is about the altitude. We get the altitude using this function, and then we are just printing it in the serial monitor, and it is coming in meters. So if you want to convert into feet, so you can use this formula and you can show it in the feet. Okay, so this is about the pressure sensor getting all the variables, and we are taking the inputs and we are displaying it. And then now we come to the electrical parameters using the energy sensor. So we have 4 energy sensors. So these are the parameters which we need to get it from the energy sensor. So this again is a predefined functions from the energy sensor header files. Okay, voltage, current of, power of, energy of, frequency, power factor. So these are the variables you will get it. So this also, these data whatever you get, you are going to print it here. Okay, so if you are using LCD, you can use the LCD to print it, and if you are just monitoring in the serial port, you can print it in the serial port. So same like that you can get for the second energy sensor: voltage, current, power, energy, frequency, power factor, and display those values in the serial monitor or LCD. The third one also voltage, current, power, energy, frequency, power factor, and then you print those values in the energy serial port. After, likewise, we can add one more energy meter 4 also. Yeah, right. So here, next one is a DHT 11. So where I declare some, again it is a function, declared function, get humidity of. So this will be stored in the variable called humidity, and it will be printed in the serial port. And DHT dot get temperature of, this is a function, so where it will obtain the temperature from the DHT 11, and it will be stored in the temperature. This is a variable where it will store the data, and it will be printed in the serial port. So once we got all the data, like all electrical parameters, and then we have a pressure, and we have a temperature, humidity, everything. So we can upload those data in the ThinkSpeak server using these lines. You can see here, ThinkSpeak write field, my channel number is, you have declared this channel number in the beginning, you might have seen that, I have explained that. And channel field 1, it is going to display voltage, power, and then this is for one energy sensor, and this is for next energy sensor. Okay, and then we can display the humidity, temperature, and we can have pressure, and then relative pressure, all those things. So whatever the values you want to be displayed, you can display here in the ThinkSpeak. If you are a free user, so you will have only 8 field in one channel. So if you are a paid user, you will get a more number of a field in a channel. So I am using only a free channel, free user, so that I can display only 8 variables. So in case if you are using this for industrial purpose or something like that, you can go for a paid version, so where you will get more number of field variables can be stored in that particular channel. Okay, so this is how it is being updated in the ThinkSpeak server. Hope you understood the code. So in case if you have any doubt about this code, you can put the doubts or whatever the questions you have, clarifications you have, you can write a message in the chat box. Or if you want the code, you can also give me your email ID in the chat box. I will forward this data, whatever I have, I will forward it to you. So this is the output what I observed in the uh, serial monitor. You can see here. So this is a code, and these are the some variables what I get. You can see voltage, current, and power, energy, frequency, power factor, and pressure, humidity, temperature. And these are for one particular set, and for the second set again we have different values here. Okay, so this is how you will get those data, and which you want to display it in the ThinkSpeak. So I have displayed these parameters. So as I told you, only 8 parameters I can upload in a channel. So I uploaded 8 values. So load voltage 1, load power 1, and load voltage 2, load power 2, and humidity, temperature, absolute pressure, relative pressure. So these are the data I uploaded in the ThinkSpeak server. So from the ThinkSpeak server, you can this is reading and displaying it, and you can write the command, so that from remote place you can control the load in your home or in your workplace. So that is very much possible. That is what the future work I need to do. So what I am going to do is like by seeing those data, say for example, if the temperature is very high, I can switch on the fan, or if the voltage is very less, I can switch off particular load. If the power factor is less, I can switch on some capacitor bank or something like that. So I can do many things remotely from just monitoring this, and I can go for a control from remote place for various parameters. So this is the project implementation. So I have not shot the video for this, but this is the picture of it. So we have 4 energy sensors, and which is connected with 4 current CTs, current transformers. So these are the 4 current transformers, and we have you know, for MCBs 20 amperes, we are going to use actually the socket outlets as my load. So that's why I have used this 20 amperes. Some these are for a future scope. If you want to connect some lighting loads, we can use this 6 ampere MCB as well. So we have the main MCB or a isolator. We have isolator here, and then we have a RCD here, and the relay unit, and these are my energy sensor Arduino Mega, and we have a power supply unit here, DC power supply unit, and this is a step down transformer. So this is the overall uh, picture of implementation, and this is for making the PCB for this one, power supply unit PCB making, and these are the steps for making the PCB. Hope it might not be much attractive to you. So that's it about this particular project. So as I told you earlier, if you have any doubts or clarification, or if you want the code, if you want the circuit or wiring diagram, please send me your mail ID in the chat box. I will send back the details for you as you require. Thank you for watching, and I'll be back with another useful project. Until then, it's me, Rajababu. Bye bye. Take care.